the next part has to do with, for example, how is it that if you're in your car and you apply your brakes and that you can actually stop you use your foot to apply a small force with your foot, and that force and that can actually make the entire car come to a stop. So how does this work? So this works by a picture similar to the ones you see over here. We have a tube with one end with a small area and a tube with a big end at the and a bigger end on the other side. So let's draw this then. So let's say that you have a tube, and one end is going to have a big area, and another end is going to have a small area. And so the way that this works is that you're going to apply a small force with your foot here. So force F1, a small force. And what you're going to observe is that if you have a car on this side here, if you apply a small force F1, you're going to create a large force F2 on this side. And the way that this works is that, actually, there's one more thing I need to talk about, the areas here. So you're going to apply a small force over the small area A1, and it's going to create a big force over this big area here, A2. So the way that this works is that the pressure, the force, and the areas can change, but the pressure is going to stay the same throughout the fluid. So that means that the pressure on this side has to equal the pressure on that side. So in terms of the equation for pressure, that means that the pressure on side 1, so F1 over A1, is going to equal the pressure on side 2, which is going to be F2 over A2. And that's pretty much it. You're going to apply a small force with your foot, F1, and you're going to create a big force on the car, F2. But you have to take into account the area of the pipes there. Here we're going to see how pressure is transmitted through a fluid. And so you see the fluid, that's the aqua color here, and you have these two open pipe or two pistons that are connected. So on one end of the piston you have a car, and on the other end of the piston you have these two people here. And so the whole idea is that the pressure is going to be distributed evenly throughout these sections here, but pressure is related to force, or in this case here the weight of the car and these two people, and also the area of these two pipes here. So let's make the area smaller and see what happens. So for now, the car isn't going anywhere, but let's see if I reduce the area on the smallest section. So as you notice, the car's height increases because there's a ratio between the amount of force exerted on this side in the area and the force exerted on that side here. The basic idea is that the bigger the area on this side, the more force is going to get exerted on this side of the car, or on this side here. So if you keep on going, making this thing smaller and smaller. So you notice there that when this area on the small section, you're able to exert a small force because these two people weigh less than the car does, but that pressure gets carried through this evenly distributed through the liquid. And what that means is that on the large side here, because this side has a large area, it's also going to have a large force, and that's why it's able to push the car upwards.